In this lesson, we're going to talk about data frames. Now, a data frame is a special class of a list. It is a list of vectors that have the same length or two-dimensional array-like structure. Creating one is easy. Let's think about some simple city data. Ahead of time, I put together some quick information about 3 different cities: Seattle, Chicago, Fairbanks. So we're going to include the city name, the population of each city, the average high temperature, and a Boolean whether it's saying it's in the continental US or not. So we're working with 3 different classes of data here: numerics, characters, and Booleans. So I'm going to run this code. And then we're going to use the DataFrame function to turn them all into a data frame. Now each column is a component of this special list. If we look at the attributes of this city dataset, it's going to return the names, the row names, and also the class. Now we can subset this data frame using the very familiar ways, such as the square bracket notation, or we can also use the $sign. You may notice that the output looks a little different. It tells us the different levels of the column slice cities. This is because the strings were converted into a factor class, and we'll talk about what a factor class is shortly. There's an argument in DataFrame that is strings as factors. The default for this is true, and it turns any string components of a data frame into factors. If we want to see them as strings instead, we simply have to add that argument at the end of our data frame function. And you'll notice the strings as factors argument has a capital A and capital F. So now when I pull out my cities, instead of showing me what levels there are, it's just going to show me the data as character strings. Now there are 2 helpful functions to get a first look at any data frame. The first is str, which compactly displays the internal structure of the argument. So I'm going to use city data as the argument. And it's going to show me the different variables that are involved and whether they're numerical, logical, or characters. It will also tell you how many observations there are. And then, of course, there's the summary function, which we have seen before. Now, the Cars93 dataset, which we have looked at before, is loaded as a data frame. So why don't we load that real quick using our data function? Well, before we do that, let's require the mass package to make sure we've loaded it. Now, when I use the class function on the Cars93 dataset, it's going to return data frame. And we can use str to get a compact look at the different variables. You can see that there's quite a bit of stuff here. And at the top, we'll see there are 93 observations with 27 different variables. Now we can see just by scrolling through that there are many factors in this data set. If we would have set strings as factors to be false, then these all would be character vectors. Now a factor set is kind of nice because a summary function of a factor set will produce a frequency table. The cylinders variable is a factor variable. So let's see what happens when we look at a summary of that variable. So these are the different types of cylinder engines, including one rotary engine, and is showing the frequency of each category. So let's talk about some data conversions. We have discussed many data types so far: numerics, strings, booleans, vectors, matrices, lists, data frames, and a couple more. They all have slight differences, but there are functions that can convert between a lot of these data types. For example, you are already familiar with as.numeric, as.character, and as.logical from an earlier lesson. Now let me quickly create a vector, a matrix, and a data frame, and we'll explore how to convert between them. So we now have a short vector, matrix, and data frame. So to convert between these different data sets, we're going to use some as.dot functions. Now we can change our matrix into a data frame using as.data.frame. It assigns column names as v1 through v4. If we change our vector into a data frame, it's just going to give it the name of that vector. Now we can also force things into a list using as.list. If we try it on the matrix, it's actually going to take each element of that matrix and turn it into its own component of the list. So this list has 16 components. And of course, if we unlist that list, it's going to turn everything into a long vector. Now, these are just a few other ways we can use the as.dot functionality. If you're ever having a problem with a function failing as it can't use the current data type, simply try one of these functions and see if you can get it into the right class. It may not be apparent now how some of these functions can be helpful, but as you start using R more often, you'll see how useful they can be. In this lesson, I gave you an introduction to data frames and factor sets, what the differences are between these and a list, and also different ways to convert between data types.